The red planet. Mars is the fourth planet from the Sun and is the second smallest planet in the Solar System, is located on 4 planets from the Sun. Mars is called after the Roman god of battle in the English language. Mars is a terrestrial planet with a thin atmosphere, a crust mostly consisting of materials found in the Earth's crust, and a core made of iron and nickel. Impact craters, valleys, dunes, and polar ice caps are a few of the surface characteristics of Mars. Phobos and Deimos are its 2 tiny, atypically formed moons. Olympus Mons, the biggest volcano and tallest peak known on any planet in the Solar System, and Valles Marineris, one of the longest canyons in the Solar System, are 2 of Mars' most remarkable surface features. About 40% of the planet's surface is taken up by the Borealis Basin in the northern hemisphere, which might be a significant impact feature. Due to the planet's identical rotation periods and tilts of their rotating axes with respect to the ecliptic plane, Mars' days and seasons are analogous to those of Earth's. Due to the low atmospheric pressure, which is less than 1% of the atmospheric pressure on Earth, there cannot be liquid water on the surface of Mars. It appears that water makes up the majority of both of Mars' polar ice caps. Mars was probably wetter and so more conducive to life in the distant past. The existence of life on Mars, however, remains uncertain. Since Mariner 4's launch in 1965, a number of unmanned spacecraft have investigated Mars. In 1976, the Viking 1 lander of NASA sent back the first pictures taken on Mars. 2 nations have successfully launched rovers to Mars, China in 2021 and the United States in 1997 with Zhurong and Sojourner, respectively. There are also future missions to Mars that are planned, such as a Mars sample return mission scheduled for 2026 and the Rosalind Franklin rover mission, whose launch was scheduled for 2018 but was postponed until at least 2024, with a launch date of 2028 seeming more plausible. Mars and its reddish hue are visible to the naked eye from Earth. Mars is frequently referred to as the red planet because of its appearance, which is caused by the abundance of iron oxide on its surface. With an apparent magnitude that reaches 2.94, which is comparable to Jupiter's and is only surpassed by Venus, the Moon, and the Sun, it is one of the brightest objects in the Earth's night sky. Since ancient times, Mars has been seen, and over the ages, it has been depicted in culture and the arts in ways that reflect humanity's expanding understanding of it. Due to the identical tilts of the planet's rotational axes, Mars' seasons are the closest to those of Earth of all the planets in the Solar System. Due to Mars's larger distance from the Sun, the Martian year is about equivalent to 2 Earth years, hence the Martian seasons are roughly twice as long as those on Earth. In the equatorial summer, Martian surface temperatures range from lows of roughly 110 degrees Celsius to highs of up to 35 degrees Celsius. Due to the thin atmosphere's inability to retain much solar heat, the low air pressure, and the poor thermal inertia of Martian soil, there is a broad range of temperatures on Mars. The planet is 1.52 times as far from the Sun as Earth, resulting in just 43% of the amount of sunlight. Mars' axial tilt is comparable to Earth's, hence if it had an orbit like Earth, its seasons would be like Earth's. The Martian orbit's relatively high eccentricity has a major impact. When it is summer in the southern hemisphere and winter in the north, Mars is close to perihelion. Similarly, it is close to aphelion when it is winter in the southern hemisphere and summer in the north. As a result, the seasons are more severe in the southern hemisphere and milder in the northern than they otherwise would be. Up to 30 degrees Celsius can separate summertime temperatures in the south from summertime temperatures in the north. The greatest dust storms in the Solar System are seen on Mars, with winds exceeding 160 kilometers per hour. These can range in size from a localized storm to massive storms that blanket the whole globe. They have been demonstrated to raise the Earth's temperature and often take place when Mars is closest to the Sun. Mars' orbital period is 687, Earth, days, and its average distance from the Sun is around 230 million kilometers. On Mars, a solar day, or sol, lasts for 24 hours, 39 minutes, and 35.244 seconds, just a little bit longer than an Earth day. A Martian year is 1 year, 320 days, and 18.2 hours long, or 1.8809 Earth years. Mars' axial tilt, which is identical to Earth's, is 25.19 degrees with respect to its orbital plane. As a result, Mars has seasons similar to those on Earth, however due to its longer orbital period, these seasons last almost twice as long on Mars. The north pole of Mars is now pointed in a direction that puts it near to the star Deneb. Only Mercury has a more prominent orbital eccentricity than Mars, which is around 0.09. There are 7 other planets in the solar system. It is known that Mars' orbit used to be substantially more elliptical. Mars formerly had an eccentricity of around 0.002, far lower than the eccentricity of the Earth today, 1.35 million Earth years ago. Mars' eccentricity cycle lasts 96,000 Earth years as opposed to Earth's 100,000-year period. Mars has a diameter that is almost half that of Earth and a surface area that is only slightly smaller than the entire area of dry land on Earth. Mars is less dense than Earth because it has 11% less mass and 15% less volume, which results in 38% less surface gravity. Rust, also known as iron, oxide, is what gives the Martian surface its reddish-orange hue. Depending on the minerals present, it can have a butterscotch-like appearance. Other typical surface hues include golden, brown, tan, and greenish. Internal structure. Similar to Earth, Mars has evolved into a solid metallic core covered in less dense components. Current internal models predict a core predominantly made of iron and nickel with 16 to 17% sulfur. It is believed that the lighter elements in this iron, sulfide core are twice as abundant as in the Earth's. A silicate mantle that generated many of the planet's tectonic and volcanic characteristics surrounds the core, although it looks inert. Iron, magnesium, aluminium, calcium, and potassium are the most prevalent elements in the Martian crust, along with silicon and oxygen. The crust of the planet has a maximum thickness of 125 kilometers and an average thickness of roughly 50 kilometers. In contrast, the thickness of the Earth's crust is typically 40 kilometers. With approximately 450 Mars quakes and associated events detected and recorded by InSight in 2019 alone, Mars is seismically active. In 2021, it was revealed that the core of Mars is definitely liquid, with a radius of roughly 1830 to 40 kilometers and a temperature of around 1900 to 2000 K, as determined by 11 low-frequency Mars quakes picked up by the InSight lander. The Martian core is around half the size of the Earth's core and has a radius that is more than half that of Mars. This suggests that the core contains other lighter elements like oxygen and hydrogen in addition to the iron-nickel alloy and roughly 15% sulfur, as it is somewhat larger than what models had projected. The rocky mantle of Mars lies on top of its core, but it doesn't appear to have a layer similar to the lower mantle of Earth. Up to a depth of 500 kilometers, when the low-velocity zone, partially melted asthenosphere, starts, the Martian mantle seems to be solid. The limit of the transition zone is located at a depth of around 1,050 kilometers beneath the asthenosphere, when seismic wave velocities begin to increase once more. A crust with an average thickness of 24 to 72 kilometers covers the surface of Mars. Thank you for watching. View more our channel videos.